This video is about defining constructors. So let's suppose we've been asked to add a constructor to our date class that we've been working on in this example in this chapter. And the constructor will accept parameters for the year, the month, and the day, and it should initialize the new date object to store that year and month and day as its initial state. So before we get started, let's review quickly what the syntax and the purpose of constructors are. So a constructor is a piece of code that initializes the state of new objects as they're being created. And so when you say something like new, when you say date d equals a new date, you're calling a constructor. Anytime you call that new keyword, you are calling a constructor. Now, a constructor, when you write one in your code, it uses this syntax here. You write the word public and then the type of your class, and then in parentheses you put any parameters you want, and in the braces you put the statements that initialize the state of the object. When you write a constructor, you don't put a return type here because it's sort of implied that the return type is your class. And if you don't have a constructor like we didn't have in the past, then Java gives you a default empty constructor that accepts no parameters and doesn't do anything except all the fields of your object are set to 0 initially. So the reason that we'd like to have constructors is because they make things more convenient for the client to initialize objects. If you look at this client program that we've been working on in a previous example, it takes us 4 lines of code to initialize a single date object. So here, just to create 2 of them, I need 8 lines plus a little more for spacing. That's no good. What we'd really like to do is to be able to write in the parameters here. We'd like to make it so that the client can pass parameters here inside of these parentheses. So something like if we could write 2009 and then a 10 for October and a 17 for the 17th of October, that would be very nice. If we try to do that right now, it's going to say that it doesn't know how to do that. It says it can't find a way to construct a date with an int in the parentheses there. So that won't work, but we'd like to do that. So if we go to our date class, we can add a constructor to enable such a thing. We saw the slide with the syntax here. We write public and then the type and the parameters, and then in the statements are in the braces there. So usually the style is that we put the fields at the top of the class, we put the constructors next, and then the methods at the very bottom. So constructors initialize the state of created objects. And so our constructor is going to say public date, and we write in what parameters we want here. Now we want them to be able to pass a year and a month and a day. And so let's give those different names so they don't conflict with the names of our fields here. Something like int initial year, like the initial value they want the year to have, initial month, and initial day. So now what we'll do here in the statements for the constructor is we'll store these parameter values into these fields up here. We'll say I want to store into the year field the initial value that they passed to me. And the same thing for month. I want to store the initial month that they passed. And the day, I'll store the initial day they passed in as parameters. That's it. Sort of deceptively simple. If you compile it, now we've got a new version of the date class. Now if I come back here, actually I can get rid of all these statements, and this line of code does work. One funny thing, when I try to compile it, it now doesn't work for me to construct a date like this with nothing in the parentheses. By writing a new constructor here, we're basically saying that in order to construct a date, you have to tell me the initial state, or else I won't let you do that. So here we're actually going to have to change this one to say 2008-2-3 to represent February 3rd. And just to show you how much nicer this is in the code, let me delete those unneeded lines, and look at how much shorter our main method has become. Now to construct those objects, it's just 1 line a piece. That's how it should be. So if I compile the date main now and run it, everything behaves the way it did before. We haven't really enabled any new features. It's just a more convenient syntax for the client to be able to construct those objects. Some common bugs that students have when they write constructors. A lot of students try to write a return type here. They'll write void or something like that. And unfortunately, Java compiles that successfully. But what you've done if you say void is you've actually written a method whose name is date rather than a constructor for dates. And so if you try to go and compile the date main, it'll say, I don't have any constructor. So that's actually a very subtle error that a lot of students run into. So if you're getting errors like that, you might want to make sure you don't have the word void here. Another bug a lot of students have is they get these assignments backwards. They'll say initial year equals year by mistake instead of year equals initial year. So this one is wrong, of course, because it takes the value from this field and stores it into this parameter instead of taking the value from the parameter and storing it into the field. So you might wonder, what is the value of this field up here? We declared it and didn't assign it anything. So what value is it that gets put into here, and what happens to this field? Well, I think if I run this main program, I might be able to see. I don't know if it'll manifest the bug or not, but I think what you'd like to see is what is the month in D1? D1 dot month, and what's D2 dot month? Or no, which one did I not turn on? I didn't. I did it to the year, so I'd like to show this bug by printing the year for each of these guys. And when I run these, I see these zeros now in the output. It turns out that the years of these objects are never initialized. If I run this in the debugger, you can see what happens actually. I guess I want to debug from an earlier point here. I want to stop my debug and run it again with a debugger breakpoint set when I'm constructing the object here, so I can jump inside of the constructor and see what happens. So let's jump in there. Now I'm inside the constructor, and you remember there's this field called this that lives inside of each object, and that lives inside the class, and it represents the object that the code is currently running on. It's that implicit parameter. And so the object initially has zeros for the state of all of its fields here. And as I step through this code, if you store initial year equals year, it stores the 0 from year into initial year. See, this 2009 gets replaced with a 0 here. That's a bug. Month equals initial month, that copies this value up into the field here. Day equals initial day, that copies this value up here. So those are both good statements. Then when I exit out of this constructor, now you'll notice D1 is here, and it has those initial pieces of state inside. So that's the bug I've got. I don't want to say this, I want to say this. And now the code should do what we expect. So that's a basic constructor there. Another thing you might want to do is you might want to have two constructors. So imagine that we have a constructor here that you can pass in a date object as the parameter, and it will use that date object's year and month and day as the initial state of the new object that's being created. So how would we do that? Well, you can go back to your date class file here, and it's actually legal to have more than one constructor in the same class if you want to. So down here we could say something like public date, and as long as we have different parameters in here, then it's legal. Now the question that we're being asked to solve is accept another date object as the parameter to this thing. So that's a little bit strange, but we can do it. It's actually legal for us to do that. We can say, I want the date of the other object that we're copying. And then all we have to do is we can just say, this date's year should be set the same as the other date's year. This date's month is the same as the other date's month. And this date's day is the same as the other date's day. Why would we want to have two copies of the same date? Well, maybe we're keeping two sets of appointments on the same date, and so we want each appointment to have its own date object. Maybe we're going to adjust some of them, but not others, so we don't want to share one object because we don't want to adjust all of them. So if you're going to use this date constructor, you could go here to this client program. You could say something like date D3 is a new date that gets its information from D1. And now if I print out all of this information here about D3, I should get the same information that D1 had. So let me compile that and see what I see. So if I run that, I'll see that the information from D1, which was like 2009 and 365 days, I'm seeing that same information down here for D3. So I think it is doing what we wanted it to do. So that's our second constructor there. One thing that's not ideal about it is that this constructor and this second constructor are very similar in terms of the body of the code. We're passing in something, we're initializing all three of these variables. So actually there's a useful way to have one constructor call another constructor. And the way that you do that is you use a keyword called this. We've already seen the keyword this a little bit in our debugging. This is a way of referring to the implicit parameter. It's also a way of calling it your own constructor if you want to. So you can use the this keyword when you refer to your fields or when you refer to your methods, but that's not so common, and we won't need to do that very much in our common programming. But it's really useful here if you want to use one constructor from within another one. So what you can do is you can come back to here and say, well, this constructor here is basically just calling this one, but the initial year is the other guy's year, and the initial month is the other guy's month, and the initial day is the other guy's day. So we can just say, I want to call this class's constructor, and I want to pass other.year, other.month, and other.day as the parameters. There's one more change I'm going to make before I'm finished with all this constructor code. We named these things initial year, initial month, so that they wouldn't conflict with these fields. But actually, there's a way that you can use the this keyword that will allow you to name these parameters exactly the same as your fields. So look, we can change these to say year, month, day here. Now, that's a problem initially because this year is a name that conflicts with this field year. But what you can do to deambiguate them is to, you can say, this object's year field should be set equal to the year parameter that's been passed. So if you say this dot and you refer to a field, that's how you disambiguate it from a parameter or local variable of the same name. So you can say this dot month equals month, this dot day equals day. And so that's a little bit cleaner. A lot of programmers like that better because then you don't have to give different names to these. You can just name them exactly the same as the fields that they're going to initialize. So if I compile that, just to prove to you that that's a successful thing to change in the code, I'll run the client program one last time and we get the same output. And those are our constructors.